Have you ever pondered the incredible power that nature holds, like the force behind tropical depressions and their impacts? Let's delve deep into this fascinating yet formidable phenomenon. A tropical depression, in meteorological terms, is a low-pressure system with organized thunderstorm activity but winds of 38 miles per hour or less. These systems primarily form over warm tropical or subtropical waters, where the sea surface temperature is at least 80 degrees Fahrenheit. The term tropical depression is derived from the fact that these systems are associated with areas of depressed or low atmospheric pressure. This is the first stage of what could potentially evolve into more severe weather phenomena, such as tropical storms or even hurricanes. Tropical depressions are a common occurrence in the world's tropical regions, with the Atlantic and Pacific Oceans being the most active basins. They form a significant part of the tropical climate and play a vital role in shaping the weather patterns of these areas. When a tropical depression forms, it may initially seem like a blessing, especially in regions that struggle with high temperatures and dry conditions. The rain brought by these systems can provide much-needed relief. But as with most things in nature, there's a flip side. These depressions can escalate quickly, bringing heavy rainfall that can lead to severe flooding. They can also trigger landslides in hilly and mountainous areas, causing significant damage and loss of life. For island nations and coastal regions, the impact of tropical depressions can be particularly devastating, disrupting lives, economies, and ecosystems. In essence, tropical depressions are part of a complex interplay of atmospheric conditions, oceanic temperatures, and wind patterns. They are a testament to the immense power of nature and the delicate balance that exists within our planet's weather system. Understanding tropical depressions is crucial to comprehending the broader picture of our planet's weather patterns. As we continue our exploration, we'll delve into the science behind these systems, their impacts, and their relationship with the pressing issue of climate change. Stay with us as we unravel the mysteries of tropical depressions. Now delve into the science behind these tropical depressions. Let's imagine Earth as a giant pot of soup. This soup, our atmosphere, is a swirling mix of gases, moisture, and heat. Just as a stove heats the pot from below, the sun warms the Earth's surface. This heat causes water to evaporate from the oceans, adding humidity to the atmosphere. The warm, humid air rises, creating an area of low pressure beneath. This is because warm air is lighter than cool air, so when it rises, it leaves behind a void. Now, nature abhors a vacuum, and so cooler air rushes in to fill the space, causing wind. This process is known as convection and is the first ingredient in our recipe for a tropical depression. But what about temperature? Well, as the warm, moist air continues to rise, it cools and condenses to form clouds. And this condensation releases heat, known as latent heat, which further fuels the rising air. The more heat that's released, the stronger the convection, and the stronger the resulting winds. This is why tropical depressions often form in regions where the ocean's surface is warmest. Now, let's talk about pressure. The area of low pressure that's left behind by the rising warm air creates what's called a cyclonic flow. This is essentially a rotating wind pattern that moves in towards the low pressure and then upwards. The Coriolis effect, due to Earth's rotation, gives this wind pattern its circular motion. So as this system of rising warm air, low pressure, and rotating winds continues to feed off the ocean's heat, it can grow in size and power, eventually forming a tropical depression. And if conditions are right, this depression could even intensify into a tropical storm or a full-blown hurricane. But remember, not all low-pressure systems become tropical depressions. Certain atmospheric conditions must be met, and the process is highly dependent on the temperature of the ocean's surface, the level of moisture in the air, and the atmospheric pressure. So the interplay between temperature, humidity, and pressure is the driving force behind these powerful natural phenomena. It's important to look beyond the science and understand the real-world impacts of these tropical depressions. Imagine the scene. The sky darkens, the wind whips up, and there's a scent of an approaching storm in the air. Suddenly, the heavens open, and a torrential downpour floods the streets, the fields, the homes. This is not just a heavy shower, it's the physical manifestation of a tropical depression. These weather phenomena bring heavy rain, strong winds, and a high potential for flooding. The rainwater saturates the soil, making it loose and prone to landslides, particularly in hilly or mountainous regions. The winds, meanwhile, can reach speeds that uproot trees, damage structures, and turn unsecured objects into dangerous projectiles. The damage to infrastructure can be immense, with houses, bridges, and roads all susceptible to destruction. This, in turn, can disrupt essential services like power, water, and communication, affecting countless lives and making recovery efforts even more challenging. And then there's the human cost. Lives are often lost in these extreme weather events, either directly due to the storm or indirectly through accidents and disease in the aftermath. Each life lost is a personal tragedy, a family devastated, a community in mourning. But the impacts of tropical depressions don't stop at physical destruction and human loss. There are significant economic repercussions too. When infrastructure is damaged, the cost of repairs can run into millions, even billions of dollars. The disruption to daily life can halt business operations, leading to lost income and increased unemployment. Agriculture, a primary source of income in many tropical countries, can be hit hard, with crops destroyed and livestock lost. In the wake of a tropical depression, life doesn't return to normal overnight. It can take weeks, months, even years for communities to rebuild and recover. Every storm leaves a mark, a reminder of the power of nature and our vulnerability in the face of it. The power of tropical depressions can cause severe disruption and devastation, affecting both human lives and the economy. The question now arises, how does climate change influence these tropical depressions? To answer this, let's consider the nature of tropical depressions themselves. These weather phenomena develop over warm ocean waters, drawing their energy from the heat and moisture of the sea surface. So, it's logical to assume that as our planet warms up due to climate change, the conditions for these systems could potentially become more favorable. Now, how exactly does a warmer world impact tropical depressions? Well, one key factor is the temperature of the ocean surface. As our planet heats up, so do our oceans. This increased warmth provides more fuel for these storms, allowing them to intensify. The result? Potentially stronger tropical depressions, which could escalate into more severe storms. And it's not just about the intensity. A warmer world also means more evaporation, leading to a wetter, more humid atmosphere. This could lead to greater rainfall during these storms, increasing the risk of devastating floods in affected areas. But there's another twist to this tale. Climate change doesn't just mean a warmer world. It also means a more variable one. With more heat energy in the system, weather patterns become less predictable, and this could potentially lead to more frequent shifts between periods of extreme dryness and intense rainfall. This variability is a major challenge in predicting the behavior of tropical depressions and planning for their impacts. Now, if current trends continue and our globe continues to heat up, what does this mean for the future? It suggests a world where tropical depressions could become more intense, more unpredictable, and potentially more frequent. This has serious implications for those living in areas prone to these weather systems, particularly in tropical countries. We're talking about increased risks of flooding, wind damage, and the associated human and economic costs. And these are challenges we'll need to face head-on as we navigate our way through a changing climate. As the planet warms, the intensity and frequency of these tropical depressions may increase, posing a significant challenge for the future. So, what have we learned about tropical depressions and their impacts? We've journeyed through the fascinating and complex world of tropical depressions. We've delved deep into the science that underpins these weather phenomena, understanding that they form when a low-pressure area is accompanied by thunderstorms that produce a circular wind flow with maximum sustained winds below 39 miles per hour. We've seen how areas of low pressure in the tropics, coupled with the right atmospheric conditions, can create these powerful systems that can wreak havoc on land and sea. We've also explored the impacts of these tropical depressions, how they can bring heavy rainfall, leading to flooding and landslides, causing significant damage to infrastructure, homes, and even lives. But it's not all doom and gloom. These weather systems can also bring much-needed rain to drought-stricken regions, demonstrating the complex and nuanced relationship we humans have with these natural phenomena. Then, we navigated the link between tropical depressions and climate change. We've learned that as our planet warms, so too do our oceans, providing more fuel for these systems to grow in intensity. This suggests we may see an increase in the frequency and severity of tropical depressions in the future, a sobering thought for those living in tropical regions. In recap, we've seen that tropical depressions are intricate weather systems born out of specific atmospheric conditions. Their impacts are multifaceted, bringing both destruction and relief to different parts of the world. And with the specter of climate change looming, understanding these systems becomes even more crucial. But remember, our exploration doesn't have to end here. There's always more to learn, more to discover. Keep asking questions, keep seeking answers. The more we understand, the better prepared we can be for what lies ahead. Understanding tropical depressions is not just about understanding weather patterns, it's about understanding our planet and how we interact with it.